Could it be that aliens from another planetary system had come in contact with the Earth spacecraft? People are bound to disturbed as invalid data was transmitted by the Voyager 1, the fastest and furthest ever spacecraft. The question now is what could have caused it? Before we continue, let's take a quick pause, like and subscribe to our channel. Now, let us get a clear view of what Voyager 1 is like. Voyager 1 is a space probe that studies the outer solar system and interstellar space beyond the Sun's hemisphere. It is the farthest human-made object from Earth constructed by the Jet Propulsion Laboratory and launched from Launch Complex 4-1 at the Cape Canaveral Air Force Station by NASA on September 5, 1977. Although Voyager 1 was launched 16 days after its twin Voyager 2 was launched, it took a shorter trajectory to reach both Jupiter and Saturn sooner. It transmits real-time distance and velocity data to Earth through the NASA Deep Space Network. The initial orbit of Voyager 1 was an aphelion of 8.9 AU, which was just a little short of Saturn's orbit of 9.5 AU. The study of the outer planets prompted NASA to begin work on the transmission in the early 1970s. Information helped Voyager's engineers use information gathered by the Pioneer 10 spacecraft to design Voyager that could withstand the intense radiation environment around Jupiter. Voyager 1 is composed of 16 hydronized thrusters and extra 8 backup thrusters, 3-axis stabilization gyroscopes, and referencing instruments. These components collectively are part of the Attitude and Articulation Control System, the AAS, that keeps the probe's radio antenna pointed towards Earth. It also has 11 scientific instruments that can be used to study celestial objects such as planets as it travels through space. The Voyager 1 has a radio communication system through it which communicates with the engineers on Earth. This system has a vast use even beyond the limits of the solar system. It has a high-gain Cassegrain antenna with a diameter of 3.7 meters that sends and receives radio waves through the 3 Deep Space Network stations on Earth. Sometimes the digital tape recorder, or DTR, of the Voyager transmits about 67 megabytes of data recorded to Earth when Voyager 1 is unable to make direct communication. Due to the fact that Voyager 1 has traveled very far away from the Earth, the signal takes over 22 hours to reach back home. There may be worries of how Voyager 1 remains powered for over 4 decades. It has 3 radiostopic theometrical generators, RTGs, with each containing 24 pressed plutonium-238 oxide spheres. At the time of launch, the RTGs generated about 470 watts of electric power. Due to the 87.7-year half-life of the fuel and degradation of the thermocouples, the power declines, but will continue to support some of its operations until 2025. An interesting thing about this probe system is that unlike other onboard instruments, their operation of the cameras for visible light is autonomous. Its camera is controlled by the Computer Command System (CCC) in the Flight Data Subsystem, the FDS, which is an image parameter table of an onboard digital computer. The CCS does command decoding, fault detection, and fault correction routines, as well as antenna pointing routines and spacecraft sequencing routines. As Voyager 1 took a short trajectory to get to Jupiter, by January 1979 it began photographing Jupiter. It made its closest approach to Jupiter on March 5, 1979 at a distance of about 349,000 kilometers from the planet's center. This closer approach allowed for greater photographic resolution, and within 48 hours most observations of the moons, rings, magnetic fields, and the radiation belt environment of the Jovian system were made. By April of 1979, Voyager 1 finished photographing the Jovian system. A number of important discoveries were made about Jupiter, but the greatest surprise was the discovery of ongoing volcanic activity on the move Io, as that was the first time of seeing active volcanoes on any other body in the solar system. This activity on Io affected the entire Jovian system because it is the primary source of matter that pervades the Jovian magnetosphere, the region of strong magnetic field. Io's volcanoes erupt sulfur, oxygen, and sodium, which were sputtering off the surface by the impact of high-energy particles and were detected at the outer edge of the magnetosphere of Jupiter. From Jupiter, Voyagers 1 and 2 went on to visit Saturn. Its systems of moons and rings after the gravitational assist trajectories were successful. Voyager 1 had its closest approach to Saturn on November 12 in 1980 with 124,000 kilometers of Saturn's cloud's tops. With those close distances, the space probe's cameras detected in the rings of Saturn some complex structures, and with the probe's remote sensing instruments, it studied the atmospheres of Saturn and its giant moon Titan. It was expected that Saturn's upper atmosphere should have had the same helium abundance as Jupiter and the Sun, but it was found that the abundance of helium is less, while almost all of the rest of the upper atmosphere is hydrogen. The lower abundance of helium in the upper atmosphere may imply that the heavier helium may be slowly sinking through Saturn's hydrogen as denser matter sinks, while less dense floats. This observation might explain the excess heat energy Saturn radiates when compared to the energy it receives from the Sun. It was also observed that the winds blow at high speeds on Saturn, as the Voyagers measured winds of about 500 ms, 1,100 miles per hour, in an easterly direction. Among the discoveries made by the Voyagers was the puzzling aurora found in the mid-latitude in the atmosphere. This is because bombardment by electrons and ions that cause auroras on Earth occur at high latitudes, but seeing such at the mid-latitude of Saturn brought about some worries. Though the rotation of Earth is 24 hours, the rotation of Saturn is 10 hours, 39 minutes, 24 seconds as observed by the Voyagers. Flyby of Titan, Saturn's largest moon, was one of Voyager 1's missions, and it occurred as the spacecraft entered the system to within 6,400 kilometers by passing behind Titan to avoid any possibility of damage closer to Saturn, compromising observations. Since studying the atmosphere of Titan was of great interest, its composition, density, and pressure were determined by studying the Voyager's measurements of the atmosphere's effect on sunlight and Earth-based measurements of its effect on the probe's radio signal, which led to the speculation of lakes of liquid hydrocarbons could exist on the surface. Its effect of the probe's trajectory was used to determine its mass. With a speed of about 17 kilometers or 11 MIS on February 17, 1998, Voyager 1 reached a distance of 69 AU or 6.4 billion miles, 10.3 billion kilometers from the Sun and recorded as the most distant spacecraft from Earth. As of 2013, it was moving with a relative velocity to the Sun of about 61,197 kilometers per hour and currently is velocitating at about 523 million kilometers a year. Although some scientists believe that Voyager 1 entered the termination shock in February 2003, but that was proven wrong as amateur radio operators from AMSAT in Germany tracked and received radio waves from Voyager 1 using the 20-meter, 66-foot dish at Bochum with a long-distance integration technique on March 31, 2006. At a distance of approximately 116 AU from the Sun, the solar wind turned sideways because of interstellar wind pushing against a helisphere, so Voyager 1 was commanded to change its orientation in March of 2011 in order to measure the sideways motion of the solar wind at the location in space. A test roll conducted confirmed Voyager 1's ability to maneuver and reorient itself without changing its course. In order to detect the solar wind, it rotated 70 degrees counterclockwise with respect to Earth. After this first maneuver, it became easy for it to change its course. As a result, resumed sending transmissions back to Earth. Voyager 1 was continuously transmitting things detected as it probed in the solar system. Before we go into other discoveries made by Voyager 1, please hit that like and subscribe button to our YouTube channel. In addition to the discoveries made by Voyager 1, it was able to detect the first Lyman alpha radiation coming from the Milky Way galaxy, which has never been possible because of interference from the Sun. Voyager 1 entered a new region, the Cosmic Purgatory, which is located approximately 113 AU from the Sun. Within this region, charged particles from the U decline by nearly half, and the solar system's magnetic field is doubled in strength as interstellar space applies pressure. As Voyager 1 continued to probe into the interstellar, changes were detected in the environment with arrival at the helipause. Voyager 1 in August of 2012 became the first spacecraft to cross the helipause at a distance of 121 AU from the Sun, as it detected an increase in charged particles from interstellar space which were normally deflected by the solar wind in the helisphere. At this distance, it took 16.89 hours to get Voyager 1. In late 2012, if not for the expected change in magnetic field direction of the Sun to that of the interstellar field, which was 10 times more intense than what Voyager 1 encountered before the termination shock, most scientists involved in Voyager 1 would have agreed that it had crossed the boundary. This boundary was expected to be the last barrier in the solar system before Voyager 1 completely entered interstellar space. With the confirmation that Voyager 1 had actually entered the interstellar medium, abandoned the hypothesis that a change in magnetic field direction must accompany a crossing of the heliopause and adopted a new model of the heliopause that no such change would be found. Compared to Voyager 2, Voyager 1 was exiting the solar system into the interstellar medium at a high speed of about 3.6 AU per year in 2013, and in 2017, its distance from the Sun was about 139.64 AU. What pushed many scientists into accepting that the helipause had been crossed by Voyager 1 was an indirect measurement of an 80-fold increase in electron density which was expected to be higher outside that within the helipause. The measurement was indirect because Voyager 1's plasma spectrometer had long been bad. 3 years ago, unexpected increase in density in the space beyond the solar system as detected by Voyager 1 and Voyager 2 space probes was reported by astronomers. The researchers interpreted the density gradient as a large-scale feature of the VLISM, Very Local Interstellar Medium. The spacecraft transmitted continuous measurements of the density of material into interstellar space. It also detected sounds on the interstellar for the first time in 2021. Something happened in May of 2022 that triggered many worries, even considering the possibilities of aliens coming in contact with Voyager 1. Mysterious and peculiar telemetric data transmitted by Voyager even though the operational status of the craft remained unchanged led to finding why the spacecraft sent invalid data. After many checks, the problem was traced to the AACS sending its telemetry through a non-operational computer which resulted in a corruption of data. Diminishing electrical power led the Voyager team to prioritize that some instruments be left on while some others are turned off. As fields and particle instruments that send back key data about the helisphere and interstellar space are necessary for the study of the interstellar region, they are prioritized to keep on operating. The cameras were deactivated and the software removed from the spacecraft after it took the first family portrait of the solar system on February 14, 1990, with the image of Earth known as Pale Blue Dot. An interesting thing about Voyager space probe is that each carries a gold-plated audio-visual disc, in case the spacecraft is ever found by intelligent life forms far from the planetary system. In the disc are photos of the Earth and the Earth's life forms, some scientific information, spoken greetings from people in 55 different languages, as well as greetings from people like the Secretary General of the United Nations and the President of the United States, as well as a medley of sounds of Earth like sounds of whales, a baby crying, waves breaking on a shore, and a collection of music including works by Wolfgang Amadeus Mozart, Blind Willie Johnson, Chuck Berry, and Valia Bolshanka. Other Eastern and Western classics as well as various performances of indigenous music from around the world are also included. Voyager 1 stands the chance of continually leading the New Horizons space probe provided it does not collide with anything and is not yet retrieved. Though the New Horizons was launched with a higher speed from Earth, it still could not be matched by Voyager 1. This is because of the benefits Voyager 1 made from multiple planetary flybys that increased its heliocentric velocities, whereas New Horizons received only a single such boost from its Jupiter flyby. With the speed at which Voyager 1 is moving, it is expected to continue to make history by reaching the theorized Oort cloud in about 300 years and pass through it in about 30,000 years. And in 300,000 years, it will pass within less than 1 light-year of the M3V star TYC 3135-52-1. Don't forget to like and subscribe to our channel for more information on Voyager spacecrafts and other interesting and educational information.